let's take a look at another problem. All right. For any, if there are any of my students listening, I'm on page 515, number 11. Page 515, number 11. Let's take a look at a problem. All right. So here we go. So page 515, number 11, we're looking at this problem, the antiderivative of 5 minus x over 2x squared plus x minus 1 dx. All right, so I want to take the antiderivative of that. And again, what's going to happen is you're going to try to use all these techniques. You're going to try to use a power rule. You're going to try to use substitution. You're going to try to use a trigonometric substitution, or is an absolute value where you got to sketch the curve and find the area under the curve. Can you get the antiderivative in these forms here? You're going to try all of those techniques first, and it turns out that none of those will work. So now what you're going to try to do is you're going to try to use this partial fractions technique. All right, so here we go. Partial fractions. So first step is to factor. We have 5 minus x. You try to factor this out. You end up with 2x and x. You end up with plus 1 minus 1. So you just factored that out. And then you check it. You get 2 minus 2x minus 1 as you get x. That might be a test problem for you, just that. If you need help factoring, your test is going to involve factoring tomorrow or the next day. You call in right now. We'll just spend the rest of the day trying to factor. All right, so but you got to call in for me to help you. All right, here we go. Let's continue. So now what we're going to do is we're going to use this technique called partial fractions. In other words, we're going to rewrite this fraction into two different ones. All right, so let's take that some variable a over 2x minus 1, and we're going to add some variable b over this linear factor x plus 1. All right, so we're going to rewrite. We're going to rewrite that. All right, so let's multiply by the least common denominator, 2x minus 1 times x plus 1. All right, so let's multiply 2x minus 1 times 2x plus 1 times that. We get 5 minus x is equal to, if we multiply this times the least common least common denominator, the 2x minus 1 cancel. You're left with a times x plus 1. And then you multiply the 2x minus 1 times x plus 1 times this. You end up with b times 2x minus 1. All right. So now we're trying to solve for a and b. Let's strategically, this is just some general equation. Let's strategically substitute in x is equal to negative 1. From the last problem, hopefully you see why we chose x is equal to negative 1. That will cancel all that out. So we end up with 5 minus a negative 1 is equal to, that will cancel. We end up with b times 2 times a negative 1 minus 1. We end up with 6 is equal to b times, that's negative 2, minus 1 is negative 3. So you're going to divide by a negative 3 on both sides, and you get b is equal to negative 2. B is equal to negative 2. All right. So now let's make x equal to, let's say, half. Hopefully you see why we're strategically choosing x is equal to half. If you put half here, that'll cancel all that out. The b will go away. All right, so now, okay, so now what we have is we have 5 minus half is equal to a times half plus 1. And if you put half here, all of this would go away. So you end up with 10 halves minus 1 half, that's 9 halves, is equal to, this is 1 half plus 2 halves. 1 half plus 2 halves is 3 halves, a. All right, so we solve them for a, multiply both sides by its reciprocal, 2/3, and the 2's cancel. 2's cancel. You end up with 3. A is 3. All right, A is 3. You might be saying, wow, that took so much time. You might be saying, wow, that took so much time, we're done with the problem. No, that's just the beginning. That's just the introduction to the problem. Here we go, let's finish it. All right, so here we go. All right, so now we have this was our original problem, but this is the same thing as the antiderivative of A, which is 3 over 2x minus 1. And then you have plus B, which is negative 2 over x plus 1. All right? So negative 2, B, which is negative 2 over 2x plus 1. And now you're taking the antiderivative of this. This is much easier. It's much easier to take the antiderivative of this versus what we had initially. All right, so now what we're going to do is we're going to take the antiderivative of these individually. All right, so what we end up with, now we use U substitution. U is equal to, I'm just focusing on this right here. U is equal to 2x minus 1. Du is equal to 2 dx. All right, so now what we're going to have is we're going to have, taking the antiderivative of this, 1 over 2, got to get rid of that 2 there, and then you can pull out that 3 as well. You can pull out that 3, okay, you can pull out that 3, and you're going to end up with 1 over u du. All right, so taking the antiderivative, pull out the 3, 1 over u du, and then taking the antiderivative of this up here. Okay, we can take the antiderivative of this right here. You pull out that negative 2, and then you take the antiderivative of 1 over x plus 1. No need to substitute there. All right, so we have 3 halves. You take the antiderivative of this, you end up with natural log of u, and u is just 2x plus 1. All right, 2x plus 1. And then here we have the minus 2, and then you'd have to take the antiderivative of 1 over x plus 1. You'd end up with the natural log of x plus 1. All right, x plus 1. All right, this would be plus c. All right, so that's about all you could do there. True enough, you might be able to simplify this. You might be able to simplify this down. That's the final answer. The textbook might try to simplify that down. The textbook might condense those terms, but generally speaking, that's the final answer.